Brian with Miss.Geek here, and I guess you could say we're back, I guess. I'm not really sure. I'm trying to get this all squared away here. But this is the new workbench, and there's not much to it yet. Right now, I've got my phone on a holder attached to a windowsill so that when I move the desk, it doesn't shake, so no more shaky cam. And I've got my handy-dandy lighted magnifier, which is currently not on because I've got no power yet because I need to get a power strip over here. I did pick up this cool work mat here, which is already filthy. It's just gross. But it's got some cool things like parts box A and parts box B, which I will probably just cut the lids off of and never use them. Never use the lids for them, I mean. So this is about 20 bucks on Amazon, but I figured it'd be kind of nice to have a place for things to not fall off my desk and onto the floor. So to start off, to restart the homebrewing side of my channel, what I've decided to do is build another DC40. So if you go to miss.geek.com, you'll see the DC40 there at the top, and you can learn all about how to homebrew it using Manhattan construction. But I thought it'd be really cool to do it this time using the W7RLF Proto boards. And the reason is because that's kind of why I built the Proto board, or designed and made the Proto boards for, is for doing this. So this particular Proto board hasn't been used. It looks like it's got some varnish on it. I'll have to clean it off. These have been sitting for quite a while. In fact, this one's kind of messed up. I'll probably pick a different one. But anyway, but there's been some opportunities for growth within the DC40 world that I want to discuss, and it's actually going to make it easier to build. So in the DC40 that Robin marks, I think AC7LX, I might have that wrong, but when Robin and I put this together a couple years ago, she put this together in LT Spice, and it worked, and it's nice. And this is a corrected version of Asher Farhan's DC40 from his website that I don't even think is online anymore. So that was originally on phonestack.com/Farhan DC40. You can go to the Wayback Machine and find it. But he used 1N41/48. And when you use 1N41/48, you have to match them to each other to get the best performance. But Steve Ranslaff, and I'm forgetting his call off the top of my head, he's in the QRP Tech group. He posted this improved DC40. Yeah, I guess he wrote down AA7 U. I'll have to check that. But anyway, he wrote down, and this is all going to be on my website once I get it going too, but I'll put links below as well. But he wrote down this schematic, this improved version of the DC40, and the primary difference here, there's actually two primary differences in these two schematics. The first and the biggest one here is that he measured a 10 dB gain, greater sensitivity, using mixer 1N5711 diodes versus 1N4148 or 1N918 diodes. And so anyway, the 1N5711 does not need matching. So not only does it higher performance, but it doesn't need matching, which means it's easier to build. So the hardest part of this build is actually the double balanced diode ring mixer. So the actual mix, the four rings, the four diodes, is no big deal. Basically, it's a full wave rectifier. But T1 and T2 can be complex to people. And I like the way I've got it, the way it's drawn out here. The way it's drawn out here is fine too. But basically, you've got a transformer that's wound. It's three windings wound around a FT3743 toroid. and it looks complex, but it's actually really simple. So each of these sides are one side of one winding. So here's a side of one winding, here's a side of one winding. And as long as you know which windings are which, it doesn't matter which ones you use, as long as you know which ones are which. So it's got one on each side. That's because this diode ring mixer operates at about 200 ohms impedance versus the rest of the radio operates at 50. So I've got a 50 ohm resistor right here, and Steve put a 47 ohm resistor right there, which is just fine. Actually, that's for the VFO in. That's a different thing. I take that back. But yeah, he's got a slight difference with the VFO in right here as well. And he put a 51 ohm, I believe. Yeah, 51 ohm. So as close to 50 ohm as you can get right here. And then here's the preamplifiers, and then this goes to an LM386, and that's how he's got his, as an LM386. So one thing I'm going to do is I'm going to order up some 1N 5711 diodes, which I've got to do yet. I'm also got to order up some LM386 stuff. I was looking in my stash, and I thought I had some LM386 modules, and I was going to use one of those, but I couldn't find it. So if I can find it, I'll use one of those, because you don't. The LM386 is a long solved problem. There's no point in building the circuit when you can just buy it for like $3 from not AliExpress, but Banggood or AliExpress or eBay or whatever. So as long as the circuit works, it's an LM386. Now there are better audio amplifiers out there, but this will work fine for this improved DC40. Now, one thing neither of these schematics talks about is a VFO, and what I'm going to do is I'm going to demonstrate probably just a simple QRP Labs VFO, because you can go buy one really easily. But if people really want a homebrew VFO, it's just going to be an Arduino and an SI5351 and a display. In fact, I've got a PCB. Let me grab one. So I designed this PCB a couple years ago. It's the BitX 4-band VFO Rev1 2021 me, Mr. Geek. And this is for a, here's the 3 clock outputs here. Here's some outputs for 5 volt, 12 volt, and ground. Here's the synth, the SI5351 using the QRP Labs breakout board, an Arduino, and then a breakout for each Arduino pin, and then IF shift, mode, memory, band, stuff that isn't going to be used for the DC40, but it's got outputs for the LCD display, for the it's got the inputs for the rotary encoder, and overall also band switching for the band switching. If you want to implement band switching and put this thing on 40, 20, 15, and 10 or whatever, you can absolutely do that with this PCB and some custom programming. In fact, I have the programming for this, and I could probably modify it for the DC40, so you could make the DC40 multi-band. There's nothing about this receiver that makes it single band except for the bandpass filter. And now that's another area where Steve made some changes here. The bandpass filter here, I should mention that, is pretty different. I'm going to use QRP Labs bandpass filters because I have a bunch of them. Now you don't need a low pass filter for this because it's not a transmitter. However, we're going to leave room for one in the future, so that in case you want to pair this with a simple CW transmitter, it'll be pretty easy to do. So in fact, we might even make that part of the project. I'm not really sure. Now, as far as getting this schematic, either of these schematics, into this board, I've obviously printed out a version of this board on paper so that I can sit here and write that down, and write it and draw out how I want to lay this out. And so I'm going to lay this out first. I'm not going to do that in this video. In fact, I probably won't even do it on video. But while I'm waiting for the parts to come in, I'm going to work on that. Probably use like a red marker or something. In fact, I need to pick up a couple markers at the store so that I can mark on this and have some color and know what each thing is. So anyhow, that's the scope of the project. If you'd like to follow along, make sure you subscribe, and I sure appreciate it. It really does help. And let me know in the comments below, and click like also if and I'm only asking because it really genuinely helps. So if this is your kind of thing and you want to follow along, do those things, and let me know in the comments below what you want to see. And yeah, that's it. So thanks for watching. I hope you were doing well, and we'll see you in the next video. 73.